hopefully you can now see my screen. Cool. So hi everyone. I'm Jason. I am the developer advocate for TensorFlow.js here at Google. And what that basically means is that if you're using machine learning in some shape or form, there's a good chance that we're going to cross paths if you're using it in JavaScript online somewhere. And a lot of people ask me about why I end up doing what I do today. So I just want to quickly show you my kind of career path today, which kind of like explains why I do what I do. I actually started off as a computer scientist back in the good old days at University of Bristol over in England. And I then went into joining various startup companies as a web engineer. It was here I kind of refined my skills to do both front-end and back-end programming. I'm becoming a full-stack engineer, and that's what I joined Google as way back 9 years ago when I first joined Google. And that allowed me to do front-end, back-end design, UX, all these things. And that allowed me to make systems completely from scratch. And with that, I could make a full end-to-end. That led me into my career of creative engineer, creative technologist, which is where I was developing one-off pieces for our top 100 customers to try and tell their story in interesting and novel ways using emerging technologies. And that's where I got exposed to machine learning, augmented reality, all these kinds of interesting topics. So after a few years of doing that, I realized that my passions were obviously JavaScript and web engineering, but I also really enjoyed the machine learning. So I then found the opportunity to combine both of those kind of topics into one job, which is a developer advocate for TensorFlow.js. But there's one thing you take away from this slide, it's that I've spent pretty much over half my life using JavaScript, and I'm very passionate about JavaScript, and I'd love to share with you why this should be considered for machine learning in today's world. So, machine learning in JavaScript, why do one even think about that? That's a great question, and first of all, it means you can use machine learning anywhere JavaScript can run, and that means we can look at the web browser, the server-side environments, desktop native, mobile native, and even Internet of Things. And if we kind of dive into each one of those a little further, you can see many of the technologies you already know and love. All the common web browsers there on the left-hand side, Node.js for the server side, React Native for mobile native applications, and we also support WeChat and progressive web apps as well. And then we have Electron for the desktop native, and we've got Raspberry Pi for Internet of Things, because Raspberry Pi just runs Linux, and on Linux you can install Node, and that means you can run TensorFlow.js. Yeah, so it's pretty cool. All right, so next slide. Basically, TensorFlow.js allows you to run, retrain by transfer learning, and of course write your own machine learning models completely from scratch if you so desire. And if you're familiar with Python already, essentially you can do all the things you know and love in Python, but over in JavaScript as well. And this will allow you to kind of make anything you might want to dream up, from augmented reality, sound recognition, sentiment analysis, and much, much more. All the things you might be doing already. Now, there's three kind of key ways that you can use TensorFlow.js. And depending on your skill level with JavaScript or your skill level with machine learning, you might prefer to use one over the other. I'm just going to go through a few common ways to do this right now. And the first one is to use our pre-trained models. These are simply really easy to use JavaScript classes for many common use cases. And you can see some of these here on the slide. We've got things like object detection, body segmentation to find out which pixels belong to a human body, pose estimation to understand the pose of a body, natural language processing, speech recognition, all this stuff exists in these nice, easy to use JavaScript classes. So even with very little machine learning knowledge, you can use these out of the box. So I just want to dive into some of these to show you what they look like when they're running, and we can see how they can be used. So the first one is object recognition, which is actually using the Coco SSD model behind the scenes. And that has been trained on 90 object classes. So it can recognize 90 different objects out of the box without you having to do anything. And you can see that this is object recognition, not image classification. So that means we get the bounding box data coming back here, as you can see with the dogs on the right-hand side. So let me just go ahead and switch to my other screen to show you this in action. So here is some actual live code running on glitch.com. I'll send all the links around after the show. Maybe they can be added to the description of the video later. And basically, I've made this code to show you how easy it is to get started. You can just fork this and check out the code in your own time. But essentially, I can click on any of these images, and in real time, I get the classifications coming back for the objects it can detect in the scene. And what's interesting here is that even though we've got multiple
hello, for the folks on the room, we move the live stream to YouTube. Please go to that link to join us on YouTube.
share a lipstick with other people, especially in the current times where that might not be preferable given the situation the world is in right now. So very, very powerful. And I just want to show you this in action as well. So let me just share a different tab here. And now you can see me again live in the web browser, and you can see the face mask on my face as I'm talking to you right now. And the thing I want to point out here is that JavaScript is super, super powerful. Oh, 1 second. I see some people saying they can't hear anything in the chat. Bill, did you change anything? Or?
No, I think I got somehow disconnected for a few seconds, so it should be fine right now.
Okay, perfect. So basically, yeah, you can see that we're doing the machine learning in real time on the left-hand side. But because this is JavaScript, JavaScript is very rich at the display of content and information. And that allows us to actually do these real-time 3D graphics on the right-hand side here. And you can see as I'm talking to you right now, I'm also rendering this 3D point cloud on the right-hand side. And, you know, very few languages could allow you to do this in such a short amount of time. Like this didn't take long to create, very much time to create. We've got things like 3.js that are very rich for 3D graphics and this kind of stuff. And even though I'm live streaming to you right now, at the same time as doing the machine learning and rendering 3D graphics, we're still getting 23 frames per second in this demo. And you should also note that I'm currently running on the CPU. You can see here I'm actually running in WebAssembly. But if I switch the context to WebGL, then we could actually go even faster by leveraging the graphics card of the machine if we wanted to. And when I've tried that in the past, that will go to more like 45, 50 frames per second in the web browser. So I'm going to go back to the slides and continue. So next up, we have body segmentation. Essentially, this allows you to distinguish 24 body areas across multiple bodies, all in real time. And it's very hard to show you this in my bedroom right now, but basically, I've got this animation to illustrate the point. And we can see here how the people are moving around the scene, and we're able to distinguish their arms from their legs, from their heads, and so on and so forth with the different colors here on the right-hand side. And even better, we can even estimate their pose, which is demonstrated by the lines drawn within the body to estimate where their skeleton is. So with this data, you could actually recognize like a gesture or a pose or something like this to then power your system. And of course, these models that I've been showing you can be used in really delightful ways. So you can see here on the left-hand side, how I'm removing myself in real time from my bedroom, much like a kind of Harry Potter effect, like an invisibility cloak. And notice how I get on the bed, it actually deforms the bed at the same time, which is really, really cool. And this is more than just a simple effect of replacing the background with a static image. The background is dynamically being updated as I move around the scene, so much more powerful. And then on the right-hand side here, I don't know about anyone else, but I'm terrible at knowing what clothing size I actually am. Whenever I go to different brands' websites and things like this, I never know what size I am. So I decided to create a tool that also uses body pics to measure myself in less than 15 seconds, and then it can automatically select for me if I'm a small, medium, or large on the website that I might be on. So I encourage people to explore using these pre-trained models to solve problems in their everyday life, because often you have a problem and you might be able to use one of these models to help you solve that problem, which is really nice. And this can go even further. It can give you superpowers. Like this guy here, this is someone from our community, and he is really passionate about 3D graphics, and he combined TensorFlow.js with WebGL shaders. And he's basically turned himself into Iron Man, and he can now shoot lasers from his eyes and mouth in this kind of fun, creative way. And obviously this is more of a fun example, but you can imagine, maybe you're in the movie industry or something like this, and you want to create a nice experience for people to try online. You can now do these kinds of creative experiences very easily, which could be a fun thing to do with your fans. And another person from our community over in France, he's used the body pics model to essentially scan any magazine. If the magazine contains a picture of a body, we can recognize where the body is, we can extract it, and we can then put it into his room in real time, and he can walk up to that body and look at the fashion or the clothing in more detail. And notice this is running on his mobile phone. This is actually running on an Android mobile phone that's like 2 or 3 years old, I believe. So it's not even using the latest mobile phone, but it's running really smoothly, and it looks really, really cool. And of course, what did I do when web developers see a cool demo? They try and add more technologies to it, right? So here I am in my room trying to teleport myself somewhere else in the world in real time. So by combining web real-time communication, WebRTC, with Mozilla's A-Frame and Free.js, I can now segment myself from the bedroom, as you can see in step 1 and 2, and then I can send that over the internet, send it to a different mobile phone, and I can then place myself in the real world, and you can then walk up to me and talk to me. I can hear you, you can hear me, and it's just like a video call, but much more immersive. So the second way we can use TensorFlow.js is by transfer learning. So once you've used our pre-trained models, you got comfortable with how to use that, then basically you probably want to go and use it on your own data. Now, if you are experienced in machine learning, maybe from Python or other things, you can, of course, transfer that knowledge to write things in code if you so want to do so. However, today I'm going to concentrate on some easier ways to do this in case you want to just experiment for fun initially. And the first thing I want to show you is something called Teachable Machine. Now, Teachable Machine is essentially a web interface that was built by Google that allows you to train JavaScript-based machine learning models in real time in the web browser. And there's several advantages of doing that, one including all the data you're using never leaves the client machine, which means even if you have a bad internet connection, it doesn't matter because it's all running locally. And of course, your privacy is also preserved because none of the data is ever being sent to a third-party server. So let's go ahead and look how we can use Teachable Machine right now. So if you go to teachablemachine.withgoogle.com, and once again, we'll put these links in the description maybe after the show. But if you just search for Teachable Machine, you'll come to a page like this. And here you can see Teachable Machine currently supports 3 different types of training, one for images, one for audio, and one for recognizing custom poses. And hopefully more will be coming soon as the team continues to release more examples. Today, we're going to click on Image Project, and we're then presented with a screen like this. And essentially on the left-hand side, we have the classes that we want to be able to recognize. And at the moment, we have 2 by default, but we can add more classes by clicking on the Add Class button if we wanted to. Now, I'm going to go ahead and fill out some of these. I'm going to call the first one Jason, because we're going to recognize my face. And the second one, I'm going to call Cards, because I've got a deck of cards in my room. So all we do now is we click on webcam, and we now get a live preview of the webcam, and can use this to sample data from the real world to then tell the system this is data of class JSON. So of course, that's just going to be me. So all I'm going to do is click on this hold to record button and just move my face around to get some variety of images of my face. So here we go. There we go. I've got about 31 images, as you can see on the right-hand side, of me captured in real time. And this will be my training data for JSON objects. I'm then going to click on webcam for cards, and I'm going to do exactly the same thing, but with this deck of cards. And I'm going to get roughly the same number of images. Oh, perfect, exactly 31. And we've now got our training data for the two classes we want to recognize. I then click on train model, and what's going to happen now is it's actually going to retrain the top layers of the network that Teachable Machine is using to try and reclassify the data with JSON and cards instead of the things it does already know about, maybe like bottles and mobile phones and humans and cats and dogs. It's going to use all that knowledge that it knows how to recognize those things to then recognize these things. And essentially, you can now see in under 30 seconds, we have a live preview on the right-hand side, which visits finished training, and you can see it's currently predicting that it thinks JSON is being shown in this live stream on the right-hand side, which is correct. Now, if I bring in the deck of cards, you can see it goes to cards. So JSON, cards, JSON, cards. And look how fast that's running in the web browser. Like, it's really performant. And not only did we train the machine learning in under 2 minutes live here today, but we can now use it, and it runs really fast too. So cards, boom. And you could imagine how you could use this for anything you wanted, such as maybe you want to recognize if you left the garage door open and you want to automatically close it after a certain time or something like this. You could use this kind of stuff to trigger things in the real world even. It's completely up to you how you would use such things. Now, the one thing to note with Teachable Machine is that this is all being trained in the web browser. So there is an upper limit as to how much training data you can provide due to the limitations of how much RAM is used per tab in the web browser and so on and so forth. So Teachable Machine is great for prototyping. It's great to try an idea out, but you might want to look into other methods that maybe will be in the next talk, in fact, on how you want to make more robust versions of this for production use cases where you have much more training data and many more classes potentially too. But if you like what you've created here, you can click on Export Model, you can click on Download, and then here's the boilerplate code. You can just copy and paste, and you can then use that on your own website to then add your own user interface and do various other things with that as you please. So that's Teachable Machine. Let's get back to the slides. Here, you can click on Export, click on Download, and then here's the boilerplate code. You can just copy and paste, and you can then use that on your own website. So Teachable Machine is great for prototyping. I want to talk about production level systems as well, and using a similar technique, we can also use Cloud Auto ML. This is a cloud-based system built by Google that will allow you to work with gigabytes of data. And you can see here someone is trying to recognize flowers. And essentially, you can simply upload folders of these images to cloud storage. And you can then click Next, and you can then choose how you want to optimize the model. So you can have higher accuracy or faster predictions or some kind of trade-off between the two, and it will try and optimize for those criteria. You can also tweak various hyperparameters and things. I believe they expose those kinds of things too. But essentially, you set a budget, and so this does cost money. That's the other thing to mention here. Cloud AutoML is a cost. But basically, you set a budget, and then it will go away and train for several hours, and it will come back with a machine learning model it thinks is best for your situation. And it will try tens of different models with hundreds of different hyperparameters, so you don't have to do any of that work. Now, once it's finished, you can actually export this to TensorFlow.js. So you'll see this little export window once it's finished training, and you can go to TensorFlow.js here on the right-hand side and download the resulting file, just like we did in Teachable Machine, but with Cloud AutoML. And you might be wondering, well, how hard is it to use those resulting files? How do you interface with that? And it's actually pretty simple. In fact, so simple, it actually fits on this one slide. So all we need to do is we can import the libraries at the top here. So we just got some HTML script tags. The top one is importing TensorFlow.js. The second one is importing AutoML library. And then on the third line here, I've got a new image that I want to classify. So this is just an image tag I've just got a JPEG of a daisy flower here, and it's got ID of daisy. But this could be anything. This could be like imagery from the webcam. It could be anything you want, right? I've just got an image here for simplicity of this slide. And then the actual JavaScript you need to write, the actual code is just down below here. We just got a function called run, and all we're doing is we're calling tf.automl.loadImageClassification, and we're just passing a reference to the model.json file we would have downloaded from the previous step. So remember when I said that we just download a bunch of files? One of those files will be a model.json file, and hopefully this is now hosted on your web server somewhere. So you just need to put the location of that file, and it can then go and load that. Now, because this is an asynchronous operation, which basically means it takes some time to execute, it takes a while to download from a server some files, we use the await keyword to tell JavaScript to wait for this operation to finish before executing the code that comes after. So this will then assign the model to the constant called model here once it's loaded. Next, we grab a reference to the image we want to classify. So in this case, I'm just doing document.getElementById daisy, which is this image above on line 3. And this is assigned to constant called image. And then finally, all we need to do is call model.classify with the image we want to classify. And once again, because this can potentially be executed on a graphics card or something like this is an asynchronous operation. So again, we use the await keyword, and then this comes back and is assigned to predictions. And all this is, it will be a JSON object, JavaScript object, that you can then iterate through in a typical for loop or something like this. And you can go through all the predictions it thinks it's seen for that image, and you can then check the confidence levels and do something with that knowledge. So in just 3 lines of JavaScript and a import, you can use the Cloud Auto ML machine learning system, which is pretty cool. And this can be used for production level stuff. We've seen people use this we'll be going to after this. So I'm going to talk about how you write code because that will take a whole talk in itself, and thankfully we have one after this. But basically, I'm going to focus on the superpowers and performance benefits of doing machine learning in JavaScript. So first of all, I just want to talk to you about how TensorFlow.js is structured. Essentially, we have 2 APIs. There's the high-level Layers API that is basically the same as Keras. In fact, if you're familiar with Keras in Python, you'll be very at home with the Layers API in JavaScript, as the functions are called pretty much the same things, and they have the same definitions. We then have the lower level Ops API, which is the more mathematical layer to do all the linear algebra and that kind of stuff. And that also exists if you want to go deeper into the code of the mathematics of things. So you can see essentially how we have our pre-made models that we spoke about at the beginning of the session. They were built upon our Layers API. Our Layers API sits on top of the Ops API, the lower level mathematical API. And then this understands how to execute in different environments, such as the client side. So on the client side, we're talking things like the web browser, WeChat, React Native, those kinds of things. And each one of those environments understands how to talk to different backends. And by backend, I mean hardware, essentially. So here we can see that we've got the CPU, WebGL, and WASM, which is WebAssembly. So CPU is always available. This is the slowest way to execute machine learning in JavaScript, but it's always there for you if you need it. If your device has a graphics card that supports WebGL, we can then leverage the graphics card for acceleration via, particularly on older devices, older mobile devices and things like this. And in some situations, it can even be faster than WebGL for smaller models, things that are under 2 or 3 megabytes in size. You can actually have a better performance by using WebAssembly. And TensorFlow.js will typically automatically use the right one for the environment that it's in. However, as a developer, you can force one or the other if you have a preference, if you know that your model executes better in one over the other. Now, the other side of the story here is the server side. Now, server side is where we use Node.js, which is also just JavaScript, but essentially this actually talks to the same C bindings that Python does. So it talks to TF-CPU and TF-GPU, which means you get the same CUDA acceleration and the same AVX support that you have and are used to in Python land. Because both Python and Node.js are actually talking to some underlying system that's actually written in C or C++ or something like this. So it's actually exactly the same pass-through, which means performance-wise, Node.js and Python for inference are exactly the same, as we'll see in just a few slides' time. So I just want to end this slide with talking about how, if you are still using Python to do your machine learning, you can actually digest this in Node.js very easily. So here, if you've got a Keras model, you can actually load this in Node.js via our layers API very simply. And if you have a TensorFlow saved model, you can load this via our ops API once again very, very easily without any conversion. So it will just run in Node.js. And there's some advantages to doing that, which we'll see in just a second. Things is we can take the TensorFlow saved model and we can use our command line TensorFlow.js converter that will take the saved model format from Python and convert it to a JSON format so that you can run it in the web browser. So if you want to run on the client side in the web browser, then you must use our command line converter to do that, or of course write it in TensorFlow.js completely from scratch. So there's the options you have for our stack. Now I want to talk a little bit about performance, and here's some results for MobileNet, which is obviously computer vision. And at the top here, we can see the difference of running on the GPU in Python and Node.js. So the top one is Python with a 7.98 millisecond inference time. And then just below that, we've got Node.js with 8.81. So for all intents and purposes, depending which way the wind was blowing when we were taking the results, this is basically the same result. It's within a millisecond or two of each other. So it's within margin of error here. So basically, inference is exactly the same with Python and Node.js. Now, what gets interesting, however, is if you have a lot of pre- and post-processing going on, so it's often in machine learning, you have data that's in some format and you need to manipulate it to be compatible as an input to your model, then you can get some significant performance boost by the just-in-time compiler of JavaScript in Node.js. In fact, Hugging Face, who are very famous for natural language processing, for their distilled-BERT model, they saw a 2 times performance increase by switching to Node.js because they rewrote their pre- and post-processing in Node versus Python. And they're then getting the benefits of the just-in-time compiler of JavaScript because JavaScript is actually compiled at runtime right in the moment, which means it can then optimize for the data that is flying around in the moment, and it can be even more efficient than other languages. So that's pretty powerful, and it's basically, you're getting it for free almost, which is really, really nice. So I just want to focus on 5 client-side superpowers. So thinking about the web browser for a second, these superpowers are hard or impossible to achieve on the server side, okay? So the first thing I want to talk about, if you're using TensorFlow.js in the web browser, the first thing is privacy. As we kind of hinted at before, in today's world, privacy is very important. Maybe you're making a medical application or a legal application, or maybe you've got a system that's working in Europe and they have all the GDPR rules. Privacy is very, very important. And by executing on the browser, none of the data leaves the browser on the client machine. And that means the user's data is secure. And that's really great. No one can intercept that because it's not being sent to anyone, anywhere. Second point, lower latency. Because there's no server involved other than the initial download of the model file itself, when you're doing the inference, there's no waiting 100 milliseconds, 200 milliseconds to ping the server and wait for the result to come back. This is especially important on mobile phones or maybe in areas where you have poor connectivity, as you don't need to worry about that anymore. Things can work offline with progressive web apps in JavaScript on the browser, and it actually acts much like a native app. Even on Android, you get the icons and things on the screen just like a native app. And then third point, lower cost. If you're not running a web server, a machine learning server with powerful GPUs and processors, you can save potentially tens of thousands of dollars per month if you have a popular website that's using machine learning and you maybe have a few thousand users. You can save a lot of money by not having to have that expensive hardware hired all the time to do the inference. The fourth point, interactivity. As I hinted at before, JavaScript from day one has all been about the presentation and sharing of content and information. And JavaScript has really rich libraries for 3D graphics, for charting, for the display of information, all this kind of stuff. And it's by far one of the most powerful languages for the display of content, generally speaking, because we've been doing it forever, essentially. And things have improved so much since I started back in 16 years ago in JavaScript. Things have got much, much more simpler, much more cross-browser compatible, cross-system compatible, and everything just works now really recently. Part 5, reach and scale. Anyone in the world can click on a link and open up a web page. If that web page happens to use TensorFlow.js, it will just work. So the same is not true if someone wants to use your Python machine learning models. In order to do that, you first have to understand Linux and install a Linux server. You then have to install TensorFlow, and that means you have to install the CUDA drivers for NVIDIA as well if you want to leverage the GPU. You then have to go to the GitHub repository and understand the code. You have to clone the code and then put it all together. And if you got it all right and you understood all of that, you're a better person than I am because often the documentation is terrible. So basically, there's a much less barrier to entry by simply clicking a link in a web browser. And linked to this, of course, is the support for devices as well. When you're executing in Python on the server side, you have to use the NVIDIA CUDA drivers, which means you're limited to NVIDIA graphics cards. TensorFlow.js can run on any graphics card that supports WebGL, and currently there's 84% of devices in the world support WebGL, which is pretty impressive. So that means even if you're running on a MacBook Pro with an AMD graphics card or something like this, it would technically run, which would not be the case in other situations. So let's flip to the server side. If we're talking about the server side now, so not the client side anymore, back to the server, so this applies to both Python and Node.js, essentially we can use the TensorFlow save model format without conversion. So if you do prefer to still use Python for your machine learning creation, that's completely fine. However, if you're integrating with a web engineering team who probably use Node.js, then it gives you the power to scale your machine learning model so the whole world can then go see it and use it. So maybe this is great for researchers because they can get feedback on their models. Instead of just 5 people on the research team using it, maybe 10,000 people around the world can try it, and they might discover bugs or biases in the model that you never even considered. Second point, you can run larger models on the client side. As I hinted at before as well, there are GPU memory limits on the client side in WebGL that you don't have when you're running on a dedicated server on the back end. So for very large models, more complex models, you might want to run those in the cloud and then kind of have the client side communicate to that over an internet connection. Third point, it allows you to code in one language. So if you already use JavaScript, that of course is a big win. And currently in the world, 67% of people use JavaScript as a primary development languages for production. This is taken from the Stack Overflow 2020 developer survey. So this is very recent information too. And this is growing over time. So JavaScript is used by many people, and that, if you're a startup as well, means you don't have to hire as many people with different programming languages. You have to maintain different code bases and all this kind of stuff. You can stick to one language, and that's very, very powerful. Fourth point, large on the client side, we've got a large libraries and modules that are available in the Node system as well. And then the fifth point, we've already talked about this, but performance. It's got the same C bindings as Python, so the same inference speed as Python, but you do get the just-in-time compiler boost for the pre- and post-processing if you do convert that to Node, as we saw from Hugging Face. So I just want to end with some resources here, and if there's one slide you should kind of screenshot today, this would be the one. And again, we can paste these links into the description after the show. But essentially, if you go to our website, TensorFlow.org/js, you can find out much more information about the project and how to get started. If you're interested in more models, check out our models page. I showed you today just 2 or 3 models. We've got many, many more available that can do very powerful things, and I encourage you to go play with them and try them out. TensorFlow.js is completely open source, just like the Python version is. So if you would like to contribute to the project, we're all available on GitHub, and we'd love to see you contribute new operations and all this kind of stuff to the project so we can have more parity with the core TensorFlow. And then if you have technical questions, we are available on the Google group for technical discussion, and the team monitors that. And then, of course, I've also got links to CodePen and Glitch, which has some boilerplate code, like the example you saw today for the object detection, which allows you to take the code that I've already written that shows you how to access the webcam, shows you how to access images on the web page, and you can just fork that right in the web browser and start hacking with it live in the web browser. You don't even need a text editor because Glitch and CodePen are text editors built in the browser, and they're very, very powerful too. So it's really fun to use those. And then finally, on the right-hand side here, If you're looking for some recommended reading, I recommend Deep Learning of JavaScript. This is a very robust book which takes you from the very basics of machine learning, like simple linear regressions and things like this, all the way to convolutional neural networks and GANs, generative networks, in JavaScript, which is very, very powerful. So if you are a beginner to machine learning, this is a great book. If you're looking to start with JavaScript, if you are new to JavaScript, you do need to know some JavaScript to understand this book. So I'd recommend taking a JavaScript course first and then looking at this book after that. So the only thing for me left to say here is come join the TensorFlow.js community. Here's just a few more animations of what people have been making. There's many, many more. If you search for hashtag made with TFJS on Twitter or LinkedIn, you'll find tons of projects that are really inspirational. I can't fit them onto one slide. We get like new things every single week. And people are using it in really creative ways. And if you make something with TensorFlow.js, we would love to see what you're making and how you're solving problems in your life. And if they're really cool, you may even be featured at our future show and tell sessions on the TensorFlow channel on YouTube. So the only thing left to say here is, what will you make? I want to leave you one more piece of inspiration. This guy from Tokyo in Japan, he's actually a dancer by day, but he used TensorFlow.js to create this really cool hip-hop video, as you see with this kind of invisibility effect using body pics. So my point here is that machine learning really is now for everyone. It's not just limited to the researchers and academics, but also for the creatives now as well, the musicians, the artists, and everyone else in between. And I'm really excited to see how TensorFlow.js can be a big part of that story to help people like this take their first steps with machine learning and use it in ways most academics and engineers may never even dream up. Who would think we'll be using it for this kind of dancing kind of video? This is really awesome. So come join the party, and if you have any extra questions, I'm happy to connect on Twitter and on LinkedIn via the links that you see here. And of course, we have probably a little bit of time. If you have any questions right now, we can take a few questions live, and I'll let Bill moderate that session. So back to you, Bill. Thank you very much.
Great. Well, thanks a lot, Jason, for the presentations. As we can see, the TensorFlow.js JavaScript makes the machine learning really powerful and easy to do all of these AI project or build applications.
It's possible to do machine learning in JavaScript. We'll see a whole bunch of interesting stuff coming out that will just inspire people to do even more with it, which would be great.
Sorry, I think I just got disconnected. Come back again.
Oh, that's fine.
Yeah, so we have a few minutes before move to the next sessions. So if we have any questions from the audience, feel free to post on the chat. We can do a Q&A a little bit.
Cool. I think everyone's in some silence. So if you've got any questions, feel free to reach out on Twitter or LinkedIn. I'm happy to also talk offline. But I guess, yes, just hand over to the next presenter.
Okay, great. Thanks. I think this is clear. Let's move on to the next session, and with Rising, he's going to demonstrate to using TensorFlow.js to build a real-time image classifier. Hi, Jason. You can take it away.
Okay, so hello everyone, and Jason, thanks for that wonderful presentation. I quite learned a lot. I learned a lot from that as well. And thanks everyone for joining this session. So quickly, I'm going to share my slide. Sharing my slides. Okay, I believe we can see my slides, so I'll go ahead. So building an image classifier in TensorFlow.js, actually a real-time image classifier. So about me, I'm a data scientist, machine learning engineer. I'm also traditionally a software engineer before I switched over. So I still use most of my knowledge and my skill in software engineering, which is not separate actually. So I still use it a lot in my data science and machine learning engineering field. Okay, work with cloud computing a lot. I love to speak and teach about data science, and I also like speaking at conferences, and I do most technical writing. And you can reach out to me on Twitter. I communicate a lot on Twitter, and also my email is also there. So these are the things that we're going to be learning in this particular session. What is TensorFlow.js, which Jason has already covered in full. So I think that's about half my slide. So I'm just quickly going to skip ahead because he covered most of the things I was going to say. So then we'll talk about how to install TensorFlow.js, which probably can be done client side or at the server side, like you mentioned as well. So I'm going to show you how to do that. Then a little introduction to the image classification, what it is. We're not going to go deep into any mathematical justification behind why they work, but I'm just going to just share with you some brief introduction to it. Then also convolutional neural networks for image classification as well, to talk about that. Then we'll talk about transfer learning, which we are going to be using in this particular application, because without transfer learning, there's no way we can build and train a very effective model from scratch in such a little amount of time, and even the resources needed. So then we're going to go straight into the particle coding exercise. Okay. So, Jason talked about all this, so I'm just going to quickly skip. But basically what I'm saying here is that TensorFlow.js JavaScript library for training and deploying model in the browser and by Node.js is similar to the Keras API. I can easily switch to TensorFlow.js because it is easy to use. Okay, it supports pre-trained model. It is fast as Python for model training, and you can easily convert models saved. Any model built in TensorFlow Keras, you can easily convert it to TensorFlow.js format. So that is a lot of things to do. So meaning you can embed any type of model as long as it is built in TensorFlow. You can easily convert it to TensorFlow.js. Okay. So I think I'll just skip through all the slides that will just go straight to the main point. Okay, so how to install TensorFlow.js or how to use it. So there are basically two methods. You can install in the browser via a CDN, or you can install client server side in Node.js. So if you're going to be using the browser, this is the easiest method of accessing TensorFlow.js. You can easily do that by just pasting this script or this CDN link in your HTML page. Okay, so it gives you access to a TF namespace, and you can easily call the models. You can see we are creating a very simple model here, a sequential model that accepts one unit as inputs. Then you can compile the logs. You can see the API is very similar to the Keras API, so you can easily look at it and easily understand it. Okay, so we just create a simple input and output, then we'll feed and train. So to easily do this, I'm just going to quickly open a VS Code tab. So I'm going to create, let me just call this test.html, so we can easily see how we can quickly test this. So on the TensorFlow page, there's a setup part where you can easily copy the CDN. So this is what we are doing here. Right script tab. So I'm going to copy this CDN, go back to I'm just going to quickly create an HTML page. Okay, so you can paste it in your header. So this gives you access to the TensorFlow.js namespace. So you can call the models, you can build, you can do everything you normally do with TensorFlow.js. So in the body, I'm just going to quickly create a script. Sorry about that. And for time's sake, I'm not going to be writing a lot, so I'm going to just copy this simple model. Okay, let's see if this works. All right, so if this works properly, we're supposed to be printing the prediction in the console of the browser. So I'm going to save this. This should be in auto save. Okay, So I'm going to save it. I'm going to open folder where this is. This is the file, and I'm quickly going to open this on my Chrome browser. Now, if we open the console, you can see the tensor that was printed out. So this means that TensorFlow has successfully installed on this particular web page just via the CDN. So you can do anything you normally do with TensorFlow.js instantly on the browser on any HTML page. Okay, so that's the first way of getting TensorFlow. Now the second method is by package manager, also in the browser. So this is also in the browser if you use package managers like Webpack and the rest. So you can easily use maybe yarn or npm to easily add this to your file, then you import it. Okay, so this is same step as before, but this is when you are using a package manager for your JavaScript web apps. Okay, so then the second method is on Node.js. So Jason mentioned that you can Node.js offers the similar runtime performance as Python, and that's quite true, even sometimes faster. So for you to leverage more power, maybe if you have a GPU and you want to leverage more power, you can install TensorFlow.js in Node. So with that GPU, just add it to your package you're choosing file, or use npm to install that. And if you have GPU supported GPU, you can also install the GPU version of TensorFlow.js. Okay. So, but in this particular application we're going to be building today, we're going to be using the browser method. So we're going to be accessing TensorFlow via the script tag. Okay. All right. So that's how to install TensorFlow.js. Now we'll move on to the next session, which is like a brief introduction to image classification. Not going to take a long time. So basically, what is image classification? So you are trying to group images based on similarity in patterns in those images. So if you take a set of images, how can you group them into different categories or into different classes? So you can see this animation here where I have cats and I have dogs. So the image of the cat can pass through a model. The model can be a neural network. It can be a traditional machine learning model. And it should be able to give you the particular class that this image belongs to. Okay, so that's image classification. And there are various methods, there are various techniques that you can actually use to do this. But CNN, which I'm going to show in the next slide, are actually the most popularly used type of neural network for image classification. Why? Because it has shown to outperform other types of models, other type of algorithms in this particular space. Okay, so convolutional neural network are a huge breakthrough in deep learning space. Okay, and it can effectively reduce the number of parameters in an image. So, for example, in traditional methods, like if you are using a traditional neural network for image classification, your image, your parameters in your network are going to be so large because you are considering each pixel in an image. Okay, so it scales, or how I put it, it kind of makes your weights and your parameters to be so large because you have to take into consideration each point in that particular image. So those are one of like the disadvantages of using traditional neural networks. But when you talk about CNNs can effectively reduce because it does something called weight sharing. So you can effectively scan through each group of pixels in an image and kind of like extract the important information in that group of pixels. So CNN can actually reduce the size of a number of parameters in an image. It can drastically reduce the dimensionality of the problem, and it can make training faster and more accurate. Okay. So for our problem today, we're going to be using something called transfer learning. So we're not going to be writing our own code from scratch, our own CNN code from scratch to try to classify images. We're going to be using a technique called transfer learning. And transfer learning is efficient because it's a way of reusing models that have been trained for one task on another task. So Jason mentioned teachable machine, so you can easily add just a few subset of images on the teachable machine platform, and it can easily classify which group that image belongs to. How does it do this? It uses transfer learning at the back end. Okay, so there's a model that has been trained already on thousands and hundreds of thousands of images. So this model already has like a basic understanding of what an image looks like. Okay, so if, for example, I'm trying to differentiate between, say, somebody, I'm trying to differentiate between a human and a dog, for example. The model, the pre-trained model, has already been trained on images of dogs and images of humans. So it already has that kind of base, like a base knowledge of this particular image. So that means I can take this model that has been trained already and plug my own new classes to it, but it is similar, okay, and leverage the already existing power that this model has already. So if you take a look at this this image to the left, you see that for the tax one, the first tax, you have the data comes in, you have the model, then you have the head of the model. So the head of the model can be your top layer, your output layer, which can be maybe 2 class, 3 class, 4 class, and things like that. Okay, then you make predictions. But for the tax 2, if we're going to be transferring this knowledge, we take just the model, we cut off the head, because, for example, maybe the model was trained on 1,000 classes, and for our new tax, we just need 2 classes. Okay, so what we do is we take this model and we cut off the head, and we can add a new head to it. So we are basically transferring the weight and the knowledge is in model 1 into model 2, and we are putting a new head. So this new head can be our new classes, new number of classes, which could be 2, 3, or any amount. And now we can take the new data, which is coming from data 2, another tax entirely, pass it through our model, and we can teach this model to learn to predict those new tasks easily. Now the training, there are different types of training for transfer learning. You can start to train the whole model again. That takes time. Or you can start to just train just the head, which is very, very popular. So you learn just the head. Or you can start to train some part of the new model, of the old model. You can start to train some part of it. Okay. So, but transfer learning is very important in the sense that you can easily leverage power of existing models. So training time reduces drastically, accuracy increases, and you can do this under a few minutes. You're already using a model to do powerful things. Why? Because you are using existing models that are available. So there are many types of pre-trained model. There's image classification, like we saw earlier, object detection, and the rest. So in this tutorial, we are going to be using a pre-trained model for image classification called MobileNet, actually. Okay, so MobileNet is efficient, and it is mobile based. It is efficient. It is built for mobile for resource constraint environments like your mobile phone. So it is not too heavy. It is light, and it is actually very, very accurate. So that's what we're going to be using in this tutorial. So basically, we are going to be taking a pre-trained MobileNet. So this is the architecture of what we'll be building. So we're going to take a pre-trained MobileNet model. Okay, and now there are different ways. Remember, I said there are different ways of actually using a pre-trained model. You can decide to take a pre-trained model and add an head to it. Then you train everything. Okay, but there's also another way that you can easily do that by using something called a KNN classifier, whereby we take our pre-trained model, we pass in an image. So, for example, this image of a person pointing up. We pass in an image, so this pre-trained model makes a prediction. Okay, but the prediction is not based on classes. It's going to make a prediction, and we're going to retrieve the activations from that prediction. Okay, so the activation is just a bunch of matrices that captures the information present in this image. So we'll take that bunch of information that captures what is in this image from this pre-trained MobileNet model. Okay, that's the vector representation of the image, and we'll pass that vector to a KNN classifier, which is like a k-nearest neighbor classifier. So this classifier is going to associate each vector that is coming, or each activation coming from the pre-trained model, to a particular class that we specify during training. Okay. So for example, this image of a person pointing up is going to pass through the pre-trained model. The model is going to predict an activation for this particular image. So that means that if this model is well trained before, it is supposed to have a similar or predict similar activations for similar images. Okay, so meaning activation or images that are pointing up are supposed to be having activations that are closer to each other. Okay, so that's what we are basically capturing here. So we capture that activation, we associate each of those activations to a particular command or a particular class. So I can decide to assign this particular activation that I've got from this person to the class up. This is just an arbitrary number of classes, which is like 5. So it can be anything, can be 2 classes, can be 3, can be 4, depending on what you're trying to do. But basically, the architecture is that we're using a pre-trained model, but we're putting a KNN classifier on top of that pre-trained model. Okay, so this is basically what we'll be building. So it's not going to be difficult because we already have the mobile net trained already. So we'll just get the CDN of this mobile net already. Then we can TensorFlow.js also provide a KNN classifier for you, so you can easily grab the CDN of this, grab the CDN of this. Just what we need to do is just to create a simple interface that can take an image, maybe from the webcam, that can call the mobile net model, make an activation prediction, takes that activation, pass it to the KNN classifier. KNN classifier assigns it to a particular class. Then we just need to do this in real time. Real time basically means from a live feed. And the live feed basically means we are starting a webcam in the browser and we are running this in a while loop or something. Okay, so basically that's what we are going to do. So enough talk. Let's see this. Let's see some code and let's see this in action. So I'm going to switch to my VS Code. I'm going to look this. Okay, so probably I'm not going to be writing everything from scratch. So I already have the app here, so that we won't waste much time. But it's very easy. I'm going to explain every part of it. Okay, so remember that we need an interface. So the interface should have a way of capturing our classes. Okay, so in this particular application, what we'll be building is probably I should run this application before. I should probably run it so I will see the output before I start explaining. So I'm going to open container folder and okay, so let's see. It's probably loading. Alright, it's downloading mobile nets from the internet, so you can see. So when it's done, when the model has been loaded, it starts the webcam. So the interface of this application is really simple. What we are trying to do is to capture training data in real time and continuously make prediction. So you can see it's done. So it wants access to the camera. Okay, so this is me live. Okay, so what this interface is doing is like we just have a video element here, and we have different control for our different classes. So each of these are buttons. So by the time I click on this once, it captures a particular image from the browser and associates it with this particular button. Okay, so I have control up for the 5 classes I'm going to be having. So our model is supposed to be detecting up, down, left, right, and when I'm doing nothing. Okay, so basically, if I click on this, let's see. Say I click on this now. So it has captured the first class, so it's 100% sure I'm pointing up. If I do another class, it does nothing because I've only added a single class to this. Okay, so if let's say maybe I add more class, I'm pointing up. So as I'm clicking on this, it's capturing an image, it's associating to that particular class. Okay, so if I click down now, maybe I do something like this for down, click on it, you can see with just 2 classes, my percentage, its prediction for pointing up has gone to 66% because it's not familiar yet with this class. I've added just a single example. So if I add more example, you can see it has gone to pointing down 66%, but it is still not too sure because the training examples are too small. So if I add another example, you can see with just 4 examples, I now have an 100% accuracy in prediction. You can see just 4 examples. I'll be able to differentiate between up, this is up, and down. Okay, so you can see how cool is that because you are leveraging transfer learning, and this is done in real time. So it's both learning at the same time it's predicting. So for class left, it can't detect class left because let's see, this is left. I've not added class, so you can see it's saying pointing down. So if I add a single example by clicking on this, this is the second. So this is just 2 examples. I have 66% accuracy. 3, yeah, you can see. So I added 5 examples and I have 100% accuracy for pointing left. So I'm going to do the same for right as well. So 3. Okay, so I have 3. Let's see. Okay, with 5 examples. My left and my right images looks quite similar, so I have to add like at least 5 examples for it to get it right. Okay, so I'm going to add a class for doing nothing. Doing nothing means I'm not doing anything, so I'm just going to add myself. Doing nothing, doing nothing, doing nothing, doing nothing 5 times. Okay, so I have this done. So I'm currently doing nothing in spreading. So if I raise my hand up, see, okay, nothing, doing nothing 5 times. Okay. So I have this done. So I'm currently doing nothing in spreading. So if I raise my hand up, see, so that's like okay, just add nothing, 5 times. So I have this done. So I'm currently doing nothing in spreading. So if I raise my hand up, see, pointing up, that's like okay, just add nothing, 5 times. So I have this done. So I'm currently doing nothing in spreading. So if I raise my hand up, see, pointing up, that's like so you can see it's quite nothing, 5 times. So I have this done. So I'm currently doing nothing in spreading. That can actually capture each of the classes that we want. So let me quickly switch back to the code here. So what we are doing first, let's take that page. So we have the TensorFlow.js library, which we import by CDN. Then we also have the pre-trained MobileNet model, which can also access by the CDN. Then we have the KNN classifier. First, let's take that page. So we have TensorFlow.js imported by CDN. Then we also have the pre-trained MobileNet model, which can also access by the CDN. Then we have the KNN classifier. First, let's take that page. So we have CDN. Then we also have the pre-trained MobileNet model, which can also access by the CDN. Down, left, right. So on click of each of these buttons, we are going to capture that particular event. On click, we capture the event, we capture a frame from the webcam, and we send that to our model to make prediction, and we associate it with class integration. So we just create 5 different, depending on the number of classes that you have. So me, I have 5 classes in this particular application. Yours can be 2, can be 3, depending on what you're trying to build. So that's basically the first part. Then we have an output where we just display the results. So you can see it's a very simple application. These are just bootstrap JavaScript query. So I'm going to many part of it, which is index.js, which is where the model is. So you can see very few lines of code, and we'll be able to do that. Why? Because we are leveraging transfer learning. So what we already did is we initialize our webcam elements, which we already did in the index. So just simply assign it to this. Now our KN classifier, which we have as 5. So let me see here. So which we have here. All right. So you can initialize by calling the .create function. Okay. So just call KN classifier .create and can assign it to this. Okay. So we have, I think I'm going to start from the starting of the app. So on loading this page, we call the app function. Okay, and this is app. So what the app function does is that first of all, we need to download the MobileNet model. Okay, so we download the MobileNet model. So we have to await for it. So because this kind of like runs asynchronously, so it takes a little bit of time. So you have to use an await to wait for that to load. So as soon as it's done loading, we have the webcam element. Okay, and you can TensorFlow.js comes with support for getting data from the webcam, so it's very efficient. So you don't have to write low-level images from the webcam. No, you don't do that. You can easily leverage the tf.data function. Just pass in a webcam element, which we already initialized here. And remember, this is coming from the video element, the 5 video tag. Okay, so you just pass that to the tf.data.webcam function, you have access to webcam. Okay, so you can capture a frame and do anything you want to do with it. Okay, so then we also assign events to each of our. So remember we have pass up, pass down, left, right, and nothing. So we assign an event click to each. So on click of each of these buttons, it calls a function called add with a integer class. Okay, so we just assign 0, 1, 2, 3, 4 to each of these classes, each of these buttons. Okay, so meaning on click of class up is going to call the add example function. And what is the add example function going to do? Simple. The add example function is just going to take 0. The meaning class up is 0. Then it's going to capture an image. This is the add example function. Capture an image from the webcam. Remember, we have access to the webcam because we initialize it here. Okay, so just calling webcam with captures a frame from the webcam. Remember, we have to await it because if you don't await, it takes some time. So if you don't await, you might be predicting on a null object. Okay, so we await for that. Then we infer or we predict on that. So the basenet model, which is the basenet, initialize the basenet. Okay, governet.load. So it's saved to this variable basenet. Okay. So from basenet, infer is going to take this image. Now remember the await the webcam.capture is going to convert those frames to tensor objects. Okay, so image is a tensor, it's just a bunch of arrays. Okay, so we can infer on that. So once you pass this to the infer function from basenet, it's going to return a bunch of activations. It just means a bunch of vectors of a representation of that particular image. Okay, so like we explained in the slides. So it takes this activation and we call the add example. So you can see most of these things have been created by the TF.js team already because they know you most of the time you're going to be using this kind of transfer learning. Here the classifier comes with an add example function that you can just pass in an activation and pass. So it associates this activation to this particular class ID. So meaning we have similar activations and they will be assigned to the same ID. Okay, so we infer to get the activations. Normally, if you were maybe you wanted to add an edge to it, for example, a dense edge to it. If you are working in Python, you can basically flatten from the base model, then you pass that to your output, or then you train it. So, but here we are basically just using a classifier to associate each of those class. And also remember to do some cleanup. We dispose the image so that we will release some of the memory. So we'll dispose that. So we are calling each class on click and adding an example. We add for 0, we add for 1, 2, 3, and 4, which are all associated with up, left, right, and okay. So now that we have that, this is happening in real time. Okay, so we're associating it with that in real time. So we just just continuously till you stop or till you close the page or till you stop the page. So basically, you can try to add a button to start and stop it, or just leave this the way it is. Okay. So what are we doing here? What we're basically doing here is to first of all we check. So maybe for example, you just load the page. You just load the page. This function is going to run. So starting on an empty image, we are first going to check if any class has been added to the classifier. Okay, so the get num of class will return how many classes are currently in the classifier. So if there's no data, so no prediction will be made. Okay, but if there are at least one class, it's going to start making prediction. And how is it making prediction? It's going to from the webcam particular prediction. So that's how we did this on the class. Okay, so if the label is 0, you can do class of 0. It's going to give us up. The label is down. Class of 1 is going to give us down. something like that. So we get the things, the prediction can be up, right, down, or nothing. All right. Then we can also get the confidence. Confidence is simply the how sure are you? How sure is the model? Percentage of how sure the model is. Okay. So we can convert it to percentage format, and we round it up to decimal places. Okay. We have the probability. So if the final position is nothing, if for example it is meaning that is nothing. So if the final position is nothing, you can just print this to the output. So this is the output that was specified in index of HTML. I have the validity, so I am 20% sure you are pointing. Oh, this is doing, not pointing that in. So just quickly, yeah. So I am 20% sure you are doing nothing. Then if it is not, so I can put the probability and also print the final press, which can be one of up, down, left, right, nothing. Then we dispose the image. Then we call the await tf.next frame. So what this does is this captures a frame, then we dispose it, and this captures the next frame. So it's going to wait for us to finish with this. Make sure we have done the prediction before it goes over to capture the next frame. Okay. So basically, that is our application. So you can see it's not quite. TensorFlow.js already comes with most of the tools that you'll be using, and you just need to just read on top of it once, and it works. So you can customize your UI to do anything you want to do, and everything works.